Hi everyone, today's video is to show a development example of STM32 eval board and T5L smart screen. This example includes three elements: the STM32 eval board, the T5L smart screen, and the PCB structure of the smart screen. The PCB structure is to facilitate video explanation. The example implements three types of control: 4 I/Os for controlling the LEDs on-off, 1 PWM for controlling the brightness intensity of the LCD, I/Os for controlling the ultrasonic rangefinder. Next, I will use the phone case to demonstrate. At this time, we can observe the change of the parameters of the ultrasonic rangefinder on the screen. The development of the above functions is based on T5L ASIC. The smart screen used in the example belongs to EKT evaluation board series. From the PCB structure, you can see some interfaces such as I/Os, UARTs, CANs, PWMs, and FSK, which are convenient for users to develop. The wiring of the example is to connect the through-hole pad of the smart screen to the STM32 eval board with dual-bond wires, while the UART2 of the smart screen is connected to the UART of the STM32 eval board. The wiring diagram is as shown. In practice, the T5L EKT series products can be directly connected to external devices such as motors via the through-hole pad. However, in general, the smart screen is more often used in combination with the STM32 eval board. These two rows are the STM hardware interface resources such as I/O and PWM, etc. For a detailed description of this part, users can refer to the STM official website. The actual wiring used by the users should be based on the needs and definitions. The wiring in the video is just to provide a reference. Industry applications such as lights for steam ovens, high-speed blenders, and soy milk makers can be controlled through I/Os or other hardware interface resources. Next is to explain the development process, which is divided into GUI development and STM32 program development. The tool used for GUI development is DWIN. The configuration files that can be parsed by the T5L ASIC are generated by DWIN's interface configuration. They contain information of touch, display, background, icons, etc. that we configure in the software. Then download the generated configuration files to the screen. And these two softwares on the left are for secondary development. The T5L smart screen is pre-installed as the underlying program of T5L OS and is mainly responsible for serial communication. If there are other needs, you can also use C51 development and download the T5L 51 bin file to the screen. When developing with C51 for the first time, there is a situation that UART cannot communicate. In that case, you can write through the UART part of the program, or you can contact the customer service to get the official program. It should be noted that the cycle of DWIN is 20 milliseconds. The above is the introduction to the development part. This picture introduces the T5L smart screen and the STM32 eval board. Once again, the hardware interface resources of the smart screen including UART, CAN, PWM, AD, and I/O can be used directly. Only the mode of I/O, CAN parameters, etc. need to be configured and enabled with reference to the T5L development guide, and the interface definition of STM32 eval board can be found in the STM official website of the corresponding model development information. Next, the program section is described. The program based on I/Os and the PWM is as follows. This is an established code with a total of 337 lines. The main part of the program is in the main function. This part includes configuration and output mode of I/Os, initialization of PWM, parameter configuration of ultrasonic rangefinder, and the specific use of I/Os. You can refer to the comments for the meaning and function of each line of code, including the ultrasonic rangefinder, timing data acquisition, and the transition and display on the screen. If users need to use a same function, you can directly refer to the code in the example. For different modules, DWIN will provide the corresponding reference code. After complete the code and click Build, a hex file will be generated, which can be converted into a bin file by using the DWIN download for 8051 tool. The DWIN software covers various touch and display functions that will be used in general development, such as icon display, touch button, etc. After the interfaces are configured, cool HMI can be realized. Commonly used various functions have been encapsulated in the controls. Only the corresponding parameters need to be configured, and one of the more important parameters is VP. The specific usage can refer to the T5L development guide. The communication between the smart screen and the eval board is achieved by means of serial data. Thank you for watching.